if we talk about the OSI model, so now firstly just see why we have to use this OSI model or why this OSI model just developed. So for that, firstly, if you will see about this OSI model, so you can see here, OSI model stands for Open System Interconnection. Open System Interconnection. That is the model developed by ISO. ISO means International Organization for Standardization in 1984. It's a seven-layer conceptual model that defines how to data transfer from source to destination over a network. Means it defines when you send the data from one PC to the another PC to the second PC, then how it will travel, how it will transfer from the source to destination in your network. But you can see this word. This word says conceptual model. That means it's only a concept. It never used in any network. Right? It's only a concept. So which model is used? If we see about that, or if we just see why it is developed. So if we talk about the before 1980s, so before 1980, which model were used? Right. So for that we can say before 1980s, in market we have only two companies. One is HP and second one is IBM. For IBM, HP and IBM were available that time. So HP system use on model and IBM system on use on model. So after that, if you want to compare with HP system with the IBM system, so you can't compare that time. That means you can only compare with the same manufacturer devices. If you want to create a network, then you have to consider all the devices of the HP or all the devices of the IBM. So that time this problem was of. So for that, if you heard about that, the first network developed by the DARPA, DARPA. DARPA means Defense Advanced Research Project Agency. Right? It's a defense agency of US military. So it's created a network that was ARPANET. ARPANET. This was the first network. So ARPANET means Advanced Research Project Agency Network. So this network created by the DARPA, and DARPA created this network for the military base. Right? For the military base, by this network they connected two military base with each other. Right? So we can also say it's about the man or van net, like the internet. It's the starting of the internet, ARPANET. So they created this network ARPANET, but they didn't describe anything on any book or any concept how they created this network, right? Which type of devices, which model they use, they didn't describe anything. So for that, some author or some we can say computer researcher just write something about this network, this type of model. So the model is TCP/IP model, TCP/IP model, right? So it is not written by the DARPA. It is written by the some different computer researcher. So computer researcher just write something about the TCP model, TCP/IP model, how they created the network, how this TCP/IP model works, how you can communicate with two devices over the internet, over the man or WAN net. So they write the whole concept in TCP/IP model. But you can also just assume this: if DARPA didn't written this type of documents, so this will not be the easy in easy form, right? So that if you just heard about the TCP/IP model, so in some books you can see the TCP/IP model layer, four layer, and in some books it's a five layer, right? Because a single person didn't write about this document. right? Multiple researchers write about that TCP/IP model, so that you can see the 4 model and 5 model in TCP/IP. But if we talk about the OSI model, so before OSI model, if you just see about this TCP/IP model, so TCP/IP model developed in 1983. 1983. So after 1 year, OSI means ISO. This ISO company means International Organization for Standardization started to uh, create the concept of the this network, means how this network works, how you can transfer the data from the source to destination in your network. So they start to written about that. So it's only the concept, it's the conceptual model, right? Only the what type of model used, that was TCP/IP model. So the OSI model is easy to understand. So you can easily understand the things, how the network works, how the source, how you transfer the data from source to destination, what steps follows in backend and in front end. So everything you can understand by this OSI model. So it's an easy model, and you can also see in this form, as we discussed in our TCP/IP model, we have only the 4 layer, or in some books that is 5 layer, right? But to create the easy concept, OSI means ISO created the OSI model with 7 layers. Right? So you can understand this concept, this TCP/IP model in deeply form in OSI model, how the network works. So this is about the OSI model, why this OSI model developed, and which model is used in real case. So in real case, it's used TCP/IP model. Right? So OSI model is 7 layer conceptual model, and that defines how to data transmit from source to destination over a network. Right? So now it's clear what's the mean of OSI model and why this OSI model developed. Yes, let me know. Then we go to next.
Yes.
Okay. So now can anyone tell me the layer of this OSI model? Just tell me the first layer. I will write it. Anyone?
Physical layer,
Physical layer. Okay. Physical. Second layer.
data link layer,
Data link layer. Third. Third layer. Any idea?
network layer,
Network layer. Okay. Perfect. Fourth layer.
Transport layer.
Transport layer. Fifth. Fifth layer.
Session.
session,
Session. And sixth. Sixth layer.
presentation,
Presentation. And last layer. Seventh layer.
Application layer.
Sorry.
Application layer.
Application layer. Okay. Application. Hmm. That's perfect. So you can see here, this is the 7 layer of OSI model. So here you can see in this format, I just connected two systems with each other. One is my sender and the second is my receiver. So if you will see in this diagram, so the first layer is physical layer, data link, network, transport, session, presentation, and application. Right? And always you have to write these layers from bottom to upside. This is the rule from for OSI model. Right? It is written by this form. But the first layer is physical layer. And when you send any data from the sender, then you are working on application layer. Always we are working on any application. Like I'm just working now in WebEx and PowerPoint. This is the application. So that means I am working on application layer. So always you work on application layer. And in receiver side, always you receive the data from this physical layer, and then data link, network, transport, session, presentation, and application. And on application layer, you can interact with that data. And if you will see here, so the uh, application layer, presentation layer, and session layer, these are known as upper layer and the software layer. Means on these layer, software is used. Any type of software it can be used. Then if you will see in bottom side, so the network, data link, and physical layer. These are hardware layer and lower. Because on this layer, hardware is used. We will also discuss which hardware is used. But for now, it's the hardware layer and the lower layer. And transport layer is used to communicate with this software layer with this hardware. So this is the mean of the 7 layer of OSI model. Now, if we will see, so mhm, you can see here. So here we have this physical data link, network, transport, session, presentation, application, and in middle side you can see this is the unit of data unit. Which type of data unit used on any layer? So you can see here on physical layer, the data unit is bits. Means your data will travel in bits, and in data link layer, it's frame. Means your data will travel in frame form. In network, it's packet. In transport, it's segment. And in this application presentation and session, this is in data form, because these are the software layer. You are working on software. So these are the in data form. So why this different units used here? Because suppose I'm just taking an example. If you want to send something by the courier from one location to another, I'm just taking an example of courier service. So what has happened? Or suppose I'm just taking the online order. If you just order something from any online site like Amazon or Flipkart. So what happened in backend? So in backend, when you order something, right, you are the user, and this is the Flipkart, and this is the Flipkart. So when you order something, so order received by this Flipkart, and Flipkart uh, means Flipkart sent this order to the shops, means by which shop you want to receive that order. So this shopkeeper, right? Suppose you order a mobile, right? So normally a mobile is normal form, is raw form in the mobile format, normal form. So this shopkeeper will pack this mobile in a box, right? So now you can see in normal form. Suppose I'm just taking the example, it's in bits form. When the shopkeeper packs this mobile, then now it's frame, right? It's in frame form. After that, that will send this to the courier service, means to the any local courier service. So the courier service will pack this in a box form, in the carton form, a big boxes. So they will pack. So that is packet form. After that, that will send to, suppose I'm just taking, uh, you just receive this order. You are in Mumbai, Mumbai, India. You are in Mumbai, right? And this order comes from Bangalore, right? So this Bangalore courier service will send this send this mobile to the Mumbai courier service. So they will pack in a box form and they will send. After that, when this Mumbai service will receive this cartoon or receive this type of boxes, so after that they will just separate your order and separate all the order which is related to the same colony or the same location or the same area, and they will again create a other box, and in other box they will just place all the boxes there which is related to that area. Suppose I'm just taking example of Andheri, Mumbai, Andheri location. This is a location in Mumbai, if you don't know. So Andheri location. So they will place all the order related to this Andheri location and then send it. So suppose this is the now segment form. You send this order or this shopkeeper send this order in normal form, in mobile form. After that, now it's changed in box form and then in the big cartoon in big box, and then in Mumbai it's again changed in segment form. After that, they will just send this to they will just give it to the courier boy. That courier boy will receive that order and just uh, go to this Andheri location and then find your location, and after that they will give you this order. So now it's in data format. After that you will unpack that mobile. You will unpack. So now you will working on this session layer means in data form. That's in data form, but you will just unpack that. And after that, normally you can just see your mobile. You will get the mobile and you can use that mobile. So now that is in application form. So we can also relate this example within this format. So in format the same thing. As we discussed, the physical data link and network layer is hardware layer. So that means different types of hardware will use on this layer. As we if we talk about the physical layer, so in physical layer, your cable and connector use cable and connector. In data link layer, your switch use network switch. In network layer, there is router use, right? So these are the hardware layer. So in cable and connector, the data in bits form. In switch, it's in frame form. In router, it's in packet form, right? So that's why these units are changed. And after that, when you just transport this by using TCP and you do some protocols by using, so that is in a segment form. After that, when you receive on any application on your operating system, so in operating system that data will be in data form, and then it will just decrypt that data, it will just uncompress that data, and then you will get the real data, the raw data. Right? So this is the process how your data uh, unit works in backend. So now just let me know if any doubt. Yes, anyone? Yes, is that clear? Uh, yes, Tomundo.
Yes. Yeah, sir. I'm joining few minutes ago.
Okay, so actually we are discussing about the OSI model.
Okay, okay, sir. I will catch up all this.
Okay. So anyone else? Any doubt? Okay, so is that clear for everyone? Yes or no?
Yes, sir.
Yes.
Okay.
Yes.
Okay, perfect. So next is now just describe one by one for all layers. First is physical layer. Physical layer means what? You can see here for OSI model, ISO also says this physical layer is the first and bottommost layer of OSI model, and it receives the data from data link layer, right, from its upper layer on sender side, and transmit the data to the data link layer on other side, right? If you just see here in sender side how this layer works, physical and the data link layer, and on receiver side the data and physical. Right? When you send this data, so this data will travel like this. So this physical layer receives the data from this data link layer. And on receiver side, this physical layer will send this data to the data link layer. And it uses cable and connectors to make a connection, as we discussed. If we talk about the responsibilities of this layer, so first is encoding. Means this layer just do encoding. Encoding means it will convert your bits because your system, your computer works on bits form in binary form. So it will convert your bits into signal because On this layer, this cable and connector is. So in cable, your data will travel in signal form. So on this layer, this data will convert from this bits into signal and vice versa also. Means on other side, it will convert into from signal into bits. So this is known as encoding. Second responsibility is transmission rate. So this layer also defines the data transmitting speed. Means the speed is will define on this layer. How it will define? So for that, your cables decide what will be the speed. Your cable decide. So cable decide means, suppose if you heard about the cables type, we are using the copper cable. Copper cable. So in copper cable, we have the category. We have the twisted pair, and we have coaxial cable. Now in computer network, coaxial cable is not used. Right? Coaxial cable earlier we used, but now coaxial cable is used in DTH connection or your disk TV connection. In disk TV, which cable you just use, that is coaxial cable. Earlier it was used in computer network also, but now in computer network this twisted pair cable used, which is known as like a LAN cable. That is twisted pair. So in twisted pair cable, we have the category. We have the category 1, category 2, category 3. This is the category of the cable. So according to the category, your speed will decide. The latest category of twisted pair cable available is category 8. And for this category 8, the bandwidth support means the speed support is 40 Gbps. 40 Gbps. 40 Gbps means 40 GB per second. And the segment length is 100 meter. Means if you are using this category 8 cable in your network, then you can send your data in, using this speed 40 GB, 40 GB per second, right? And the segment length will be just 100 meter. So on this layer, this transmission rate also decided. After that, transmission mode. Transmission mode means what? The direction of data flow will also define on this layer. Means what will be the direction you are sending or you are receiving. So everything will decide on this layer. And you are using the simplex mode, half duplex mode, or full duplex mode. So it will also decide on this layer, physical layer. So as we discussed earlier also, the mean of simplex, half duplex, and full duplex. And who don't know, so you can also see here simplex. So simplex means what? If your device is working on simplex mode, that means only one device can be the sender and the other one can be the receiver. We have the example television remote. Television remote, if you have the television means TV and you have the remote. So only this remote can be the sender and this TV, this television can be the receiver. Right? Second is half duplex. In half duplex, both device can send and receive the data, but not at same time. Right? Both device can send data, but not at same time. Suppose we have the example how Bluetooth. If you don't know about the hub, the next topic is network devices. There we will discuss about this hub. But for now, we have the Bluetooth. I think all of you knows about this Bluetooth. If you send the data from one mobile to another mobile using Bluetooth, then only one device can be the sender at the same time and the other one can be the receiver. Once the process will complete, after that the second device can also send the data from that device to first device. So this is half duplex. Last is full duplex. Full duplex means both device can send and receive the data at the same time. At the same time means, suppose we have the example mobile phone. We have also the example in computer network, that is switch. But if you don't know more about the switch, we will also discuss in network device chapter. But for now, we have the example mobile phone. Right? When you just connected with anyone on the call, so at same time you can just say anything. But you can interrupt. So that is possible by this full duplex. That is the transmission mode. right? So that's all about this physical layer, what the physical layer responsibilities and how it's work. Now let me know, is that clear or any doubt in physical layer? Yes, is that clear for everyone?
Yes, sir.
Yes.
Okay, perfect. Next layer is data link layer. So now see how this data layer, link layer works. So if we see in this data link layer, so this is the second layer of OSI model. Okay, it receives the data from its upper layer. So the upper layer is network layer, and then convert the data into frame, because as we discussed in data unit. So in data unit, as what we discussed in physical layer, the data form is bits. Oh, sorry, in network layer, because it receives the data from the network layer. So in network layer, the data form is packet. Then from this packet form, this data link layer converts that packet into frame form, and then this will attach the header and the trailer. Attach the header and the trailer. What is header and trailer? So you can see here, header means what? Header contains the 48-bit MAC header, 48-bit MAC address, by which your switch and your devices can understand from which device that data sent, or for which device that data will be sent. Right? So header contains the 48-bit of MAC address of the sender and the receiver. Right? So it has both of the data. Like suppose we are taking the example of, for you just courier something, you have the box, and in this box you just put something like the mobile. I'm just taking again the example mobile. So if you want to send this data, this box from one location to another, then you will just put one slip, and on this slip you will write the sender address and the receiver address, and then you will send. So we can say this is the header where you can place the address of your sender and receiver. So same thing is there. Header contains the 48-bit MAC address of the sender and receiver. And trailer is used for the error control. Right? Error control means suppose you just want to do it fast, then you can use speed post. Right? Speed post. So that is the trailer. So trailer will control the error. If any error will occur in switch form in data link layer, in means in switch device, that it will try to control. And the data unit of this layer is frame, as we discussed earlier. So what is frame? We will talk about. So frame, we can say frame is the format where the 1518 bytes contain. 1518 bytes, as we discussed in that example where we mobile phone. So what we have done, we just packed this mobile and we just sent it to the courier office, and then courier office will pack this box in the big box and the big carton. Means in that carton has multiple this type of box available. So same thing is there. What's the mean of this frame? Frame means this switch will pack the 1518 bytes into a form, and that form is frame. Right? So here in this layer, in data link layer, convert the data into frame and then attach header and trailer, and then forward the data to the physical layer, to the next layer. And after that, from physical layer, it will send to the next side, to the receiver side, and on receiver side, it will just receive the data. Means this data link layer will receive the data from the physical layer and remove the header and trailer. Right, from sender side, it attach the header and trailer, and in receiver side, it will remove the header and trailer, and switch will see for which device this data has to be sent, and then just forward the data to the network layer. Right, so this is the process of this data link layer. And if we talk about the responsibility of the data link layer, so first is framing. Framing means in on this layer, the data will be converted in frame form. The physical addressing, header will attach. Yes, in header, you can find the physical address, the MAC address. Error control. Here we have the trailer. So trailer will control the error. So these are some responsibilities of the data link layer. Right. So now let me know. Is that clear or any doubt? Yes, clear.
Yes.
Okay. Anyone else? Not clear.
Please.
Okay. After that, next layer is network layer. So what is the use of this network layer? So as we discussed also, then on network layer, router works. So if we talk about the network layer, so this is the third layer of OSI model, and it receives the data from the transport layer and convert it into the packet. As we discussed in transport layer, the data is in segment form. So it will receive from the transport layer and then convert it in packet form and then forward it to the next layer, the data link layer. At the receiver end, it will receive the data from the data link layer and forward it to the transport layer. So what's the use of this network layer? So it selects and manage the best logical path and data transfer between nodes. So if you just see here responsibility, so first is routing. Routing means what? It is the process to find and select the best route. So as we router work, suppose we have the network. We have this network, we have this router, and we have multiple router connected in same network. This router and this router. We have also this router, this router. These are connected with each other. I'm just connecting with the cable. So these are connected with each other. This is my first router. This is second, third, and the fourth one, five, six. If I will send my data from this first router to this fourth router, actually, I have to add some more router also. One router more. So this is my one more router. Okay. So now if I will send this data from first to this fourth router. So what will happen? We have two ways. We can send this data from this side and from this side also. So what will happen? This router will decide the best logical path. Best logical path means what? In routing means in ccna part, we have the routing types. We have three types of routing available there. Static routing, default routing, dynamic routing. In dynamic routing, we have some protocols by which the router can automatically decide that by which path he has to send the data. It has to send the data. So how the router will work? So router will decide. Suppose I am using a routing protocol which works using hop count. Hop count means hop count. Hop count. Hop count means the router which is available from source to destination. Like if I'm just sending the data from this first router to fourth router, so hop count is in this side on upside. This first router one, then two, then three, right? Three, and then this is the four. So we have the four router on this side, and from second side, this is the first, the second, and this third. So there is three router. So if we that protocol using hop count, so the data will be sent from this side because here hop count is less, that is three. So it will decide on this network here. Then next is logical addressing. Logical addressing means what? On this layer, IP address will work because if you want to connect two devices in a network, then you have to need the logical address, the IP address. Logical address. If we talk about the physical address and logical address, so can anyone tell me difference between physical address or we have the example of that physical address is MAC address and for the logical address that is IP address. So what is the difference between them or why we have to use these two types of address for a single device? Just any idea? Can anyone tell me?
Switch using MAC address, router using IP address.
Okay, but why we have two types of address? Uh, that is also the possible when switch will manufacture that time the IP address also works on switch. Or if we just forget the switch, in earlier we have the hub. In hub case, there is not any types of MAC address used by the hub. Okay, so now see what is the difference between them. Actually, physical address and logical address means what? Physical address is something which is assigned by the manufacturer. Manufacturer means to identify physically your devices, right? To identify physically your device. If I am just taking an example, suppose I have a person. I have a person, right? And the name of this person is Ajay. Ajay, right? So this address is MAC address. MAC address means physical address of this man. Physical address Ajay, right? By this name, this man will be identified. And if this Ajay or if this man wants to join a network means suppose we have a university or we have the coaching or we have the suppose organization. I'm just taking the organization. Organization that is HCL, right? Ajay is the employee of this HCL organization. So what will be the identity for this organization? Because in HCL we have multiple Ajay, right? If you will check the database of the HCL, so we have lots of Ajay available, right? Lots of Ajay available, like 10 or 20. So how HCL will identify to this Ajay? So we have this SAP ID, SAP ID. I think all of you have the SAP ID also. So HCL will identify you by this SAP ID, but at the last, by SAP ID, they will identify you physically. Okay, this SAP ID is for the Ajay. Right? So that's why in network we have to need a logical address, and in network, logical address is the unique address. It can't be same in single network. Suppose you just say, or suppose we just taking the example of this HCL again. So in HCL, this is not possible. The same two SAP ID cannot be assigned for any person, right? SAP ID is unique, so that is logical address. And this physical address, this physical address is the identity of this Ajay of this man, by which they can be identified physically, but for the organization or for the network, it has to need a logical address by which they can work in our organization or in a network. Otherwise, physical address can be same in that network as we discussed. So this is something about the logical address. So difference between physical and logical address. Is that clear? Now let me know. Is that clear?
Yes.
Yes.
Okay. Next is internetworking. Internetworking means what? The responsibility of this network layer is also to connect two or more network, because to connect two or more network is called internetworking. So how this works actually? Router is used to connect two different networks. Suppose we have the network, we have this network. I'm just attaching this switch, and with this switch I have some devices like this and this, and this is my network. And the IP address of this network is 192.168. 10.2 and the 10.3, and we have another network. This network is located in Sri Lanka and this network is located in Bangladesh. Right, so here we have two devices and the IP address of these devices is, suppose we have 10.0.0.1 or 2 10.0.0.2. This is the IP address. So if you will see here, so these are the different networks. If you want to connect these two networks, so we have to need a device that is used to connect two different networks. So we have router, this router. So firstly you have to connect this router with your switch, and then you have to connect these two router with each other. Right? In one case, we can connect these two router with using the internet, and if you have the if you if it is available in physical location, so you can connect it by wired also. After that, you have to do the routing on this router, means you have to add the network, you have to add the information about this network, then it can be able to connect with that network. That is known as internetworking, to connect two or more different networks. Right? So now let's go to next layer. Next layer is transport layer. So transport layer means what? This is the fourth layer. It receives the data from the upper layer and convert them into known segment, unit segment. Right? As we discussed on this layer, unit segment is used, and then pass these data or unit to the network layer, to the next layer, and ensure that all the pieces arrive correctly at the other end. Hence, this is the responsibility of this layer to send the pieces on other side correctly, right? And that you will talk about the responsibility one by one. So first is service point addressing. Service point addressing means what? The responsibility of transport layer is to transmit the message to the correct process known as service point addressing. Means if we are taking the example, suppose we have this switch, right? And this is a 24 port switch, and this port has 24 ports. And I'm just connecting one, two, three PC and one more, four PC. I'm just connecting them. My first PC is connected on first port, second is connected on second, third is connected on third, and fourth is connected on fourth. So if I will send my data from this first PC to the fourth PC, so how in internal process this switch will send this data from first port to fourth port? If I will send data from first PC to fourth PC, that means this switch will send the data from first port to fourth port. So internally, how this will identify the correct process on which port it has to be sent. So it is known as service point addressing. So this work also just do on this transport layer. And segmentation and reassembly. So segmentation and reassembly means when the transport layer receives the message from the upper layer, it divides the message into multiple segments, and each segment is assigned with a sequence. So that means it will assign a sequence number on each segment, and at receiver end, transport layer reassemble the message based on their sequence number. So why this sequence number? They can just arrange in uh, correct sequence, right? Otherwise, if it will not assign any sequence number, then suppose you just send a 10 segment, 10 segment, or we can say 10 pages of a file. So what can be happen? So it can be happen. Suppose if you send first, second, third, fourth, fifth, this type of segment, then first is sent. On second, there is some error. Okay, second is not sent. Then third is sent. Then on fourth, fifth, and sixth, there is some error. Then seventh is sent. So it can be. Then when you receive the data on other side, then you will get the first, third, and then seventh, then ninth page. So this will be the some data something like which you can't read. So for that, this transport layer will just doing these things, like just create the segment and then assign the sequence number. Firstly, Just first segment will send. After that, if any error will occur on that second, then uh, then it will show you the error. Means you have to solve that error. Otherwise, uh, any other segment will not send. Right. So this is the case in this transport layer. After that, connection control. Connection control means transport layer is responsible for making a connection and from source to destination. Means when you make the connection, so in backend it is used to make the connection also. Suppose I'm just using WebEx. I'm just open the WebEx and just type the meeting ID and the password and then click on join. When I click on join, after that in backend, this transport layer will work and it will try to connect my WebEx application with the another WebEx by which I'm just I want to attend the meeting. Right, so it is completed by this transport layer. Error control. So as we discussed, the responsibility of this transport layer is to send the pieces correctly at the other end. So error control is also the responsibility of this layer. So the transport layer is also responsible for the error control. The sender transport layer ensure that message reach at the destination without any error. So these are some responsibilities. Now let me know any doubt in this transport layer. Yes, is that clear?
Yes, sir.
Anyone else?
Yes, sir.
Not clear?
Clear.
Else candidate? If you don't answer, I understand that you are not listening. You are only connected with the meeting.
Clear, sir. Clear, sir.
Okay.
Yes.
Hmm. Now next layer is session layer. So as we earlier discussed, session layer is the software layer, right? So it is work on any software. So it is the fifth layer of OSI model. It is used to establish, terminate, synchronize, and manage the connection between two pieces. Right? Responsibility of this layer is synchronization and dialogue control. So if we talk about the synchronization, suppose as we discussed is the responsibility of this layer is also to establish, terminate, and synchronize the session or the connection. So we can also see, suppose we are just taking the example of this WebEx again. So this is my WebEx. When I just type the meeting ID and the password, and when I will click on this join. So firstly, this session layer on software level, it will create the connection. It will just establish the connection. After that, their transport layer will work. Then that transport layer will connect this session layer with the hardware and it will send that uh, segment, packet, and frame to other devices or the other side. Right? So session layer means session layer is also responsible for the established connection. Responsibility is synchronization. Synchronization means what? If a system is sending a file of 400 pages, so it will add checkpoint on every 50 pages because it is recommended. Why? Because after 50 pages, it will show you the acknowledgement of success if it is successful. Or if it is not successful, so it will show you the error. So suppose we are just using this web app. If my internet connection will disconnect, then what will happen? It will show me the error. Right? Otherwise, it will show me the time. Right? So 3 hour, uh, 3 hour completed, 4 hour completed, 5 hour completed. So it will show me that thing. So that is the acknowledgement. So it is showing by this session layer. by this software. So we can also take the example. Suppose I'm just taking the example. If you see any race means we have this ground. On this ground, we have some player who is just doing racing. So we have 10 players. 10 players start uh, racing from here, and we have some checkpoint also available on this ground. On this checkpoint, we have the referee. So they will say, okay, first player pass, second player pass, third player pass, and on the name of player, suppose Ajay is on the first number and the Vijay is on the third number, or the last number. And on second checkpoint, we have other referee. It will just say our player is not able to go again. So everything is available for the acknowledgement or for the error. So the same thing is here on session layer. This checkpoint will show you acknowledgement or the error. This is also the responsibility of the session layer. And then dialog control. Dialog control is same thing like the established connection, terminate connection, synchronized connection. So you can see here this layer allowed two systems to start the communication. You establish the connection with each other. No matter you are using half duplex or full duplex mode, it can be work on both uh, transmission mode. So this is the session layer. Now tell me, is that clear?
Yes, sir. Clear.
Okay. Next is presentation layer. So now what's the mean of this presentation layer? So presentation layer is the sixth layer of OSI model, right? It deals with the syntax and semantics of the data exchange between two pieces. It acts as a data translator for the network. So the transport layer is known as syntax layer. Syntax and semantics means what? It will deal with your data. Deal with your data means suppose we have the file of a song. We have the file of a song. So it will check which type of data is available. Okay, it's a audio file, and how is they will just identify on which application it has to be run. So by this extension. So extension means what? Extension is the uh, uh, semantic, right? Extension is a semantics means MP4, MP3, I think, MP3, MP3, right? Or I think we have some more WB. We have some more extension also available for the music file, right? So MP3, and this song means this audio files is like the syntax, with which type of data available on your file. So this layer will deal on that data. Responsibility of this layer first is translation. Translation means it will convert the data from sender dependent format, is from your format, into common format that your system can understand in binary form, and then change the common format into receiver dependent format at the receiving end. On the other side, it will change that format which system can understand to the receiver dependent. If you send the music, then firstly this music will convert into the binary form, and on the other end, it binary form again convert into the music form. The next is encryption. Encryption is the process of converting the sender transmitted information into another form. So on every operating system, we have some encryption method available by which any data when you send, or on any application, we have also the encryption. When you use any application in backend, some encryption also works. By that encryption, your data will encrypt, and on other side, that data will automatically decrypt. Then only the receiver can see that data. If any attacker will attack on your network, then in network, if they able to access your data, then directly they can't read that data. Firstly, they have to just uh, decrypt that data. So it depends. which type of encryption your application use. Like suppose I think all of you just heard about the Wi-Fi encryption. If you are using hotspot, then there you can see some encryption, WPA, WPA2, WPA3, right? So that is the encryption. When you use your Wi-Fi connection, your hotspot, when you allow to connect any device with you, then when you send the data or when you share the internet connection, then your data will send in encryption form. If any attacker will attack on your hotspot on your device, so firstly they have to just decrypt that encryption, WP or WPA2 or 3, which you are using. So then they can just access your data. Compression. Compression means data compression is the process of compressing the data. Means on every operating system in backend, when your data will saved on your hard disk, so data is saved in compressing form. Firstly, it can compress and then send. And in network we have some utility. If you want to just compress the data, so we have the zip, rar. I think you heard about that form, zip file, rar file. And in Linux we have some more utilities like xzip, gzip, bzip2. So that is the compression tools by which you can just compress your data. Suppose your data is 4 GB, so you can compress it, and you can change the size from 4 GB to 3.5 or 3 GB, depend on the compression tool. So that is the compression. So all these things where you just doing on your network, so that is works on this presentation layer. After that, the last layer is application layer. So application layer, it's a uppermost layer of OSI model. This is the last layer. It is also the known as user interface, right? Means any user interact with this layer. So it provides services such as email, remote management. Means any service which you are using on network, that is work on this application layer. Because always when you doing anything on your network, so that you are doing on any application. Like suppose I'm just connected with you in network, so I'm using WebEx. This is my application. So I'm working on this uh, application layer. Suppose I'm just searching something on Google, so I'm using my browser, Google Chrome. That is the application. I'm just connected with any device using using remote. So I'm using on any software like remote desktop protocol, remote assistant protocol, which we earlier did. Or responsibilities of this layer, what you are just doing on the network. So we only do on network like file transfer, file access, file management. If you are accessing something on internet like on Google or any Facebook or any site, that means you are accessing something from that server, right? If you just upload anything, you are just file transfer. Or if you are just changing something, that means you are just managing something. So the responsibility of this layer, if you are working on any application and you are just doing file transfer, access management, or mail services, if you are using any mail services like Google, Gmail, and the Yahoo Mail. So if you just forward the mail, store the mail, so everything you are working on the application. Directory services. If you are access the global information about various services, means we have the like you can say on if you are working on cloud, so that is the directory services. So everything you are using on application. So that is the OSI model. Means OSI model defining how the data transfer from source to the destination. So when you send any data in network, so data will send in 7 steps easily. So you can understand this. Firstly, the data will send from the application layer, then it will goes to the next layer, means in presentation layer. So in presentation layer, it will just translate, it will encrypt and then compress, then send to the session layer. In session layer, it will make the connection and it will just create the connection and it will assign the checkpoints. After that, the transport layer will work. Transport layer will just create the segment and then assign the sequence number. After that, data will goes to your router and then router will just convert it in packet form, and just uh, check your IP address, and according to your IP address, check the routing table, and then uh, create the routing process. Routing process means select the best logical path, then data sent to the data link layer, and in data link layer, the data will uh, convert in frame form and attach the header and trailer, then send to the physical layer. So this is how your network is work. Now just let me know if anyone has any doubt, or is that clear?